So guys, next we are pleased to welcome Mrinal, Ravi and Ivin, Senior Solution Engineer from IBS Software. With their experience in SRE, they will share valuable insights on optimizing reality and performance. Please join me in welcoming Mrinal, Ravi and Ivin. Please.
Hi, all. Good afternoon. So, we know that you might be a little bit sleepy after that lunch. So, we try our best to make this session engaging and exciting. So, have you heard about Crossplane before? Anyone? Yeah, I see a few hands. So, if you haven't, no worries. This session is just for you. So, I'm Mrinal and this is Ivin. We both are Senior Solution Engineers SRE at IBS. And we are here today to give you a short intro and demo to Crossplane. It's a Kubernetes-Native IaC for infrastructure management. Over to you, Ivin.
Thanks, Mrinal. So, hi everyone. So, it's so great to have you all here today. So, together we can dig into today to a topic actually that is gaining a lot of traction in cloud native world today. Okay, but I would love to start with a disclaimer that we are not professional speakers, but we are here with what we have with us today. So, in this session, we will be dealing with, we will give you a short introduction on what is Crossplane, and then we will see what are the different Crossplane components, and we'll try to understand how it actually works. And then we will highlight some of the standout features of Crossplane. And finally, we will wrap our session with a short demo to showcase how Crossplane comes into action in real world. Okay, then we will be happy to take your questions as well. Okay, when talking about Crossplane, before that, I hope that we all are aware about Kubernetes and how Kubernetes helps us to manage containers. But as cloud native world grow, we face a challenge like how can we manage all other resources, like other infrastructure resources, which are not knative, but which are highly essential for modern applications. So that's where Crossplane comes into picture. So Crossplane is one of the incubating CNC of project, which is made available to us in the form of a Kubernetes add-on. So it helps platform engineers to orchestrate and create or provision cloud resources or any infrastructure resources, no matter where they run. It can be any cloud providers like AWS, Azure, or GCP. But throughout this session, we will be guiding you with examples of provisioning resources basically in AWS cloud provider. Okay, then Crossplane actually it converts Kubernetes into a universal control plane, enabling us to manage not only the containerized applications, but also but your entire cloud infrastructure. Just imagine that we are able to provision your entire cloud infrastructure just the way you do with Kubernetes objects. Okay, for that, actually Crossplane, what it does is like, when we use Crossplane, it creates Kubernetes CRDs or custom resource definitions to represent these external resources as a native Kubernetes object. And the interesting part about Crossplane is that it keeps on watching the state of the external resource that it provision, and it provides the feature of state enforcement. I can make it clear with an example. Like if I am provisioning or creating an AWS, an EC2 instance in AWS cloud using Crossplane, okay, then after a while, somehow or accidentally, someone came and deleted or terminated that instance from AWS console. But the interesting part is that you will see that deleted resource reappearing in few minutes. Isn't it that amazing? Yes. So Crossplane is that powerful. So what Crossplane really does behind it is, it acts as a control loop and it keeps on observing the external resource that it have provisioned. And when it find any difference in the state of the resource that it provisioned, then it will act upon it. Okay, so by that, I hope that I gave you a very high-level idea on what Crossplane really is. Now we are gonna see the different components of Crossplane, what it is made of. Okay, let's start with provider. Okay, when talking about provider, it is that Crossplane component that is actually responsible for all aspects of creating a Kubernetes non-Kubernetes object or non-Kubernetes resource. Okay, to make it clear, like if I want to create a S3 bucket in AWS, then I must make use of a provider called AWS S3 provider. And similarly, for any resource in any cloud that we need to provision, there exists a provider that we must use. Actually, it is creating another set of CRTs for every external resource. And then we have provider config. Okay, provider config, it is something like that deals with the authentication, like we need to connect to a cloud to provision a resource in a cloud. So it comes with all kind of, like, we need some authentication. If I want to connect to a AWS cloud, then I need to pass the secret access ID, secret access key, that credentials I have to pass. So that part is actually taken care by provider config. And then we have managed resource. It is the key concept of Crossplane. Like any resource that is created and managed by Crossplane, it is called managed resource. So for every resource out there in the cloud, it is mapped to a Kubernetes object in our cluster. So if we are just to provision an individual resource or just a single resource in the cloud, then these are the basic components that we need to be aware of. But at an enterprise level, we know that we need a collection of such managed resource. So the multiple managed resource that is made available to us in the form of a single Kubernetes object, we call it as composite resource or just XRs. And to create this composite resource, we need something called composition. So composition is just the template where we mention whatever managed resource that we want to create, in which order we want to create. So the blueprint or the template file is known as composition. And also we need composite resource definition or XRD. Okay, about XRD, it is something that is used to define the schema of a custom API that is used to expose the composite resource that we create. And that custom API created by the platform team can be used by the application or developer team to provision a composite resource in the cluster. And finally, we have claims. So claims is the only part that is being taken care by the application team. It is just like composite resource, but it will be namespace coped. So with that, we came up with the components of Crossplane. And now we can see how all these components work hand in hand or to make the whole Crossplane. So we are showing an example of provisioning some resources in AWS cloud. So this is the Kubernetes cluster we have. And before that, I want to explain this. I want to divide it as duties between platform team and the application team. So it is the responsibility of platform team that they will install Crossplane in the cluster along with all its core components. And then they will identify whichever managed resources are to be provisioned in the cloud. So let's say like it can be compute, like EC2 instance, storage or network, whatever it be. So then they will arrange or compose that managed resource with the help of composition to create a composite resource. And to expose this composite resource as a custom API, they will make use of XRD or composite resource definition. And a type of abstraction is actually happening here, like to ease the work of application team or enabling them to provision a resource in the cloud very easily. Like application team can make use of XRD. Like they don't want to allow application team to change any security features of the resource they are provisioning, but they can allow the application team, say if they are provisioning an EC2 instance, the application team can select the EC2 instance type or the size of the instance. So keeping that as parameters for user input, we can create XRD, and finally we can expose the composite resource as a custom API to the application team. And now what application team have to do is they have to create the claims. The claims would be different for different applications. And on creating the claim, it will go on and create a composite resource. A composite resource is created. That means the managed resource that is specified in the composition will get created. And then Kubernetes API will detect that, and the core components of Crossplane will provision the corresponding resources in the AWS cloud or whichever cloud by making use of the underlying provider and the credentials we have given. So this is how it works together. Yes. and we talked a lot about Crossplane. And now I want to highlight some of the standout features of the Crossplane. Okay, but there are a lot more, but I'm picking out very few. The very first thing that attracts engineers about Crossplane is that it is designed natively for Kubernetes. It is the only IaC tool currently available, which is Knative, and that it is multi-cloud supported. And the very wow factor about the Crossplane is that it have the capability of drift detection and the correction abilities, and it provides us the seamless dynamic provisioning with the help of composite resource and claims, and that it is an open source, growing open source community, so we can expect more and more advancements in future. So with that, we dealt with a lot of things about Crossplane in a very short time, but we will learn more things, or we will understand more things when it is in action. So now Mrinal will be taking you through a short demo on how to provision a single resource in AWS cloud. So over to you, Mrinal.
Yeah, thanks, Ivin. So I'm in my Minikube cluster. You can try out this in even EKS, ZK, or in Azure Kubernetes cluster also. So for easiness, I'm using my Minikube cluster here. The first step is to install the Crossplane in our Kubernetes cluster. For that, I'm using Helm. Helm is the package manager for Kubernetes. So we can install the Crossplane in the Kubernetes cluster using Helm. So once it is installed, we can verify that installation by our general commands kubectl get ports, because these components will be created as the Kubernetes object port. It is still under creation. Yeah, as you can see, it is running. And the next step is, actually in this exercise, we'll be creating an S3 bucket. So we need to install the AWS S3 provider for that. And for Crossplane, there is a marketplace called Upbound. So all the documentation regarding all the providers available in the Crossplane will be listed here. So I'm using AWS family, and under that, we'll be using S3 provider. You can search for that here. And we can use this manifest file. I have this in handy. Yeah, this is the thing. So we can install using our general command kubectl apply file name. So once it is installed, now we can, our next step is to authenticate our Crossplane to our AWS cloud. So as you know, in AWS we have credentials. So I've copied my credential in the secret file. We have access key ID and secret access key. So out of this text file, I'm creating a Kubernetes secret out of it. So I'm creating a secret called AWS secret new in my Crossplane system namespace. So once it is created, we can see the status of that secret. So as you can see, this is our new secret. And out of this secret, we'll be creating a provider config. So provider config is that where we are authenticating our Crossplane to use our AWS cloud. So this is how it looks. The kind is provider config, and the name would be default one. And we are referring the newly created secret here. And that is AWS secret new. So we'll be creating the provider config here. We can see the status of provider and the provider config using our general commands. Get provider. You can see the provider AWS S3 is in still false state. It would be become true in few seconds, and we can get the status of provider config. It's done. So once this is ready, then we can create our S3 bucket in our account. So for that, we need a template. So this is the template to create an S3 bucket. So actually we are provisioning an individual resource here, but in enterprise level, we may need to create multiple resources at the same time. Maybe EC2 for bucket, like for storage, we need bucket and some DynamoDB at one go. So we need another components like CRD, compositions, etc. But in this simple example, we'll be creating an S3, and using this template file, we can apply this one. And it accept the name of the bucket. It should be random, as you know. Our bucket name would be unique across all accounts, and the parameter it actually accepts is the region. So we need to provision our bucket in certain region. So I am using US West Fund for that. Let's apply this one. Yeah, so you can see the new bucket is created, and it is mapped to our Kubernetes object bucket.s3.aws upbound. You can see the status of the managed resource using kget managed. So once the bucket would be created, the ready state will becomes true. You can see the new bucket will be coming in our AWS bucket, AWS account. Yep, this is the newly created one that is just created now. So actually, this is where we manage our AWS resources using Crossplane. But the interesting part is when some user tries to delete this bucket accidentally from the console, the Crossplane will recreate it in few minutes. We can try that one, but the reconciliation takes few minutes. So what we can do is we can delete this one first. The ready state is still true because there is a provider behind this. We can see. So there is one provider, AWS S3. This pod will keep on watching the object, but the reconciliation takes some time. So what I'm doing is I'm trying to delete this pod. This pod will reappear quickly. When I again get pods, I can see the new pod will be coming. So what happens is when the new pod comes in, it will directly go and check that resource is still present in the AWS cloud, and it detect that drift. You can see. So the ready state becomes false because the Crossplane identified that there is a drift in the real configuration, and when we try to access this bucket again, the new one is created just now. Actually, Crossplane is that much powerful. Why I deleted this one? Because the reconciliation takes some time, but we have limited time, so that I just deleted this pod so that it can recheck that one again. So as you show here is an individual example to create an S3 or an EC2, but at enterprise level or a production level, we need these many components. I hope this is visible. Okay, so we need composition, we need XRD, we need API to expose it to user, these many files. So composition is the main thing where we define our template. So let's say I need to create a set of EC2, Dynamo and S3 at one go. So there will be a resource field and it accepts an array of resources. So in the first one, I'm giving EC2 and its spec like EC2 parameters are this type of that instance, AMA ID, region where it would be deployed, like that. And the next one is DynamoDB and its spec, and the next one is S3 bucket. So whatever resources that you need to create, you can add it in the array of resources, and once it is ready, the platform team can accept certain parameters from the user. Like they don't need to alter any security specifications, but they can flexible with some inputs that can be given using XRD. Let's say here I have given the user to provision that particular resources in certain region. They can pass region names like EU or US. It will be mapped to region, US West 2 and EU. And you can see that user will be taking care of only these file. So there will be API exposed, AWS example.com, v1 alpha 1, and there will be a kind. And user is only passing a parameter called spec, and once it is applied, the what all resources that is configured in the template would be created. So that's how it works in an enterprise level. And that pretty much we need to cover. And we are open to any questions. Yeah.
Will it affect the suppose this running Kubernetes cluster where you configure the Crossplane, suppose it got restarted, will it affect the Crossplane resources you just created?
Actually, the resources won't get affected, but as you see, the Kubernetes cluster itself downgrade, the Crossplane and its components will be created again.
Okay. And apart from the resilience, any key difference from Terraform with Terraform?
Yep. Actually, the main thing is it can detect and autocorrect that one. And other things like importing existing resources. Actually, Crossplane is also supported, but not that much flexible like a Terraform.
If there are any no more questions, then we can just wind up. Thank you all.
Yeah. Thank you.